welcome back everybody. Well, we finally got the FE heads done. We started on the top end of this build. So I'm going to show you footage, walk you through what we did on these. I did a bunch of filming and I'm going to edit it down and I'm going to show you the whole process of rebuilding the cylinder heads for this thing. My buddy Michael was over here a while back, I don't know, about a week ago or so, and he's like, man, you're really an FE nut, aren't you? And I'm like, no, not really. I mean, he says, look at all these heads, man. And so we started counting the FE heads, and just in the head shop here alone, I've got like 15 sets of FE heads. And then we were looking at the core bank out back, and we counted 6 or 7 pallets of FE heads, probably 40 or 50 sets in total. And I was like, well, you know, I guess maybe I am kind of an FE nut. I never really like envisioned myself that way, but man, do I got a lot of FE heads. So, but anyway, I hope you enjoy this. We're gonna back up to the beginning where we started working on these, and I will talk to you again at the end. We're virgin heads, they'd never been done before, and of course, we need to disassemble these, take them apart, and clean them. So our first order of business here is to get these cores apart, because we got to get a little deeper into it and make sure that they're not cracked or anything like that. I know that these heads have never been done before. They were on an original engine, so, and they are the medium riser heads. We are also going to check some some low riser heads, which is a bigger port, and see which one is going to work best for it. So once we get these apart, then we can magnaflux them and go on from there. Now that we've got the heads disassembled, we're going to take and clean all this up with a wire brush, because we got to magnaflux them, and all these parts are going to get discarded. We're not going to use any of this stuff. We just need to make sure that these cores are good candidates. So once I get this cleaned up, we'll magnaflux them and see how they look. Alright, so we've cleaned this head up a little bit now. It's not as clean as it needs to be. If you look at some of these areas here, we still got, you know, a lot of cleaning to do. But one of the things that we do when we're doing head inspection is we clean the port area and the areas of the head that are prone to cracking good enough so that we can use our electromagnet on it. This is a magnafluxer. You don't want to spend a lot of time cleaning a head that may possibly or potentially be cracked. So we clean it just good enough to check these seat areas and some of the critical areas of the head for cracks. So we're going to magnetize that area. We're going to sprinkle mag powder on there. And so far we're looking good. We don't have any cracks here. They're really susceptible or prone to cracking in the exhaust seat area. So we're going to check all 4 of those real good. We're also going to check the top of the head. We're going to go 2 directions here. We're going to go back in a diagonal direction the other way. And if there is a crack, this thing's going to pick it up. It creates a magnetic field and it will pull this magnetic powder into it. Okay, so this head looks really good. I don't see any cracks in it. Alright, so we'll flip it over, make sure the other side's not cracked. And once we get that done, we can clean it up some more and then we'll start the machining process. So now that we've established that there's no cracks, the next thing we want to do is you want to take we take a straight edge, and this is a precision straight edge. It's not just some random piece of steel. We take a feeler blade and we check to see if we have warpage here. This is about a 2/1000 feeler blade, and we don't really have any warpage to speak of on this head. In fact, you can still see the machining lines on here. We are going to go ahead and skim cut this head anyway, just to true it up and make sure we got a good surface here, but we're just going to skim cut it because they're really flat, and we're just going to do a real shallow cleanup. We don't want to make this chamber any smaller than we need to. So the next step, we're just going to skim cut these. Now you'll notice the head looks a lot cleaner. That's because we put it through the blasting, the shot blaster to clean it up. Once we verified that it was magnaflux and so forth, we went ahead and blasted it in preparation for machining. Once we get done milling it here, then we can start working on the seat and guide situation. Like I said earlier, we just did a skim cut on this. We really didn't have a lot of warpage on these heads, but we wanted to go ahead and skim cut it and mill it and make sure it was completely trued up and a good surface. And now we can start looking at the seats and the guides in this thing. Okay guys, so next we've got our surface machine, so we got a nice true surface on this thing, and now we've got it set up. This machine is what we call a seat and guide machine. So what we've done is we want to put guides in this head, and this is our new valve that is going to go in there, and of course this is a replacement guide that we have on here. This guide is going to press into that hole. Now the factory 390 heads have what we call integral or integrated guides. In other words, that guide in there is actually made out of the metal of the cylinder head. So what we have to do in order to get these in is we have leveled this guide completely level in both directions to this chuck head here, and we have what we call a core drill in here. If you look closely at this core drill, this end of the core drill down here is just slightly smaller than the inside diameter of this guide, of the existing guide. So it is actually going to pilot into that hole, and then of course the drill steps up here, and then it's going to bore that out. So what's that's going to do is that's going to give us a hole that's about 3 thousandths smaller than the diameter of this replacement guide. These guides are designed to go with this core drill, and what that's going to do for us is it's going to allow us to press these new guides in so that we have real good guide clearances. I don't want to make a video of me boring that in guide completely out. That would be like the most boring video ever, but we'll get started and I'll kind of show you how this works here. Okay, so you can see all the chips there, and you can see that we have bored that hole. And the next step is to press that guide in. All right, guys. Now we've got the hole drilled, and this tool here has kind of an interesting name. It's called a guide driver on a pneumatic hammer. It basically has a pilot that goes into the guide, and it drives that guide in. So we'll put a little bit of lube on that. And we're going to drive it in. This is a special kind of lube that has it's really adhesive and it sticks to the guide very, very well. So we'll put a little bit of that on there. And we just take our guide and we drive it in. Okay, so you can see, if you take a look at this, try to move this without disrupting the video too much. See there, we've got that new guide pressed in. And of course, we're going to do that with all these. These all have to be bored out and replaced. And they're all going to look like that when we're done with them. So I'll go ahead and get the rest of the guides in. And then we'll start talking about these exhaust seats, because these exhaust seats are integral or integrated too. And they are actually part of the metal of this head, so they're really not compatible with unleaded fuel. So we have to put a hardened steel seat in there. We're going to use a seat cutter to cut a counterbore there, and then we're going to press that seat in, and that's going to upgrade these heads and make them compatible with unleaded fuel. Okay guys, so we made a tool change here. Our next step, and this is our counterbore cutter that I was talking about. And it's an adjustable cutter. So what we've done is we have set the cutter for about 8 thousandths smaller than the seat that's gonna go in there, because it has to be a press fit, because we don't want the seat to fall out, obviously. But we're gonna press that hardened stellite seat in there. But first of all, we have to cut a counterbore. And we've set the machine up so that we have the right depth here for the seat that we're putting in, and that seat is going to go in there. So we just run our tool down here, and I've got the stop set at the correct depth, so the machine is automatically going to stop for us once we get to the right depth. So we can actually just cut this baby. Okay, so if we take a look at what we got here, of course we're going to vacuum all the chips out of there and so forth, but that is your counterbore. And now that we've got the counterbore established, we can, once we get this cleaned up, we can take a driver and press our seat in there. But we're not going to do that on the machine, because I really can't, I don't want to pound on this cradle, so we got to take it off to do that. So this is our counterbore that we cut. This is our seat that we're going to install in there. This is our seat that we're going to install in there. It goes right in there. So we're gonna pilot this pressing tool on. There's a chamfer on one side of the seat. That's our hardened seat. We're just going to take our tool like this, and we're going to press that seat in. Like I said, it's a pretty tight fit, because you don't want these coming out. Now the seat itself at this point is just a blank. It's not really compatible to our valve. I mean, our valve's going to go in like that, but we still have to do the valve job on this thing, and that basically consists of cutting these angles. So now we're going to take the head and we're going to set it back up on the machine, and I'm going to show you how we get the angles on this thing. Okay, so we've made another tool change here, guys, and what's super cool about this is you've probably heard the term 3-angle or 5-angle valve job. This is a Sun & cutter, and you can buy different cutters. We've set this cutter up and located our 45-degree angle on our cutter here so that matches the size of the exhaust valve that we're using. We have a fixture for doing that, so it's set in place, but it's going to cut multiple angles at once. So we use a solid carbide pilot, and we have a spring. The spring just kind of gives that a little cushion and keeps it from chattering. And then we just set this up so that our driving head can turn that. And we go ahead and cut all three angles at the same time. I'll see if I can zoom in on this a little bit so you can see what we're doing.